This is question 3 from the Matric paper P2 in February-March 2015. So question 3 reads, in the diagram below, points P, Q and S are given. So we've got the coordinates 5, 13 for P, -1, 5 for Q, 7.5 and 8 for S. And SR and PQ are parallel. So SR and PQ are parallel, where R is the y-intercept. So R intercepts this y-axis. So R is on the y-axis, and X intercepts the S. The x-intercept of SR is B, which means where SR hits the x-axis is this point B. So B is on the x-axis. And Q and R are joined. So the first question, question 3.1, is calculate the length of PQ. So we want to find this length PQ. And this is the formula for the length of a line segment. So this comes from Pythagoras' theorem. If we've got a right angle triangle, then the sum of the squares of the two shorter sides adds up to the square of the longer side. So if we square root the sum of the squares of the two shorter sides, we'll get the length of the longer side, and that's what we're looking for here. So let's have a look and see what are the lengths of the two shorter sides. So going across this way, we've go from -1 at Q to 5, -1 to 5. So this is 5 minus -1. It's going to be 6. I'm going to go 6 across, and going up, we're going to go from 13 to 5. So 13 minus 5 is equal to 13 minus 5 is equal to 8. So, and the gradient is actually up over across, so that would be 8 over 6. And the length of PQ is going to be the square root of the sum of the squares. So that's going to be 6 squared plus 8 squared, which is square root 36 plus 64, which is actually the square root of 100. So square root of 100, we take the positive answer, is 10. So the length PQ is 10. And question 3.2 is calculate the gradient of PQ. And as you can see, we've already done that, because up over across is the gradient. Gradient is going to be 8 over 6. So that's the answer to 3.1 and 3.2. So the answer to 3.1, PQ is 10, and 3.2, gradient is 8 over 6. And we can just simplify that by noticing they're both even numbers. So that's going to be 4 over 3. The next question is determine the equation of the line RS in the form AX plus BY plus C equals 0. So the line RS. So here's the line RS. Now what do we know about the line RS? Firstly, we know that it's parallel to PQ. So we already know the gradient of RS. and also we know this one point, the coordinate of this one point here, S. So question 3.3 is asking us to find the equation of this line RS in the form AX plus BY plus C equals 0. Okay, we've got this information that we know the gradient of RS is 4/3, and we know this coordinate. So this is enough to solve the problem. So let's start with what we know as the equation of a line, y equals mx plus c. And we know m is the gradient, so this is y equals 4/3x plus c. Okay, but we still don't know what c is, but we can use the other piece of information. We've used this piece of information, now we're going to use this piece of information. So what's this information say? It says that when x is 7.5, y is 8. So let's put those in. So I'm going to write 7.5 is actually 7.5, so that's going to be the same as 15/2. And the reason I'm going to do that is because it makes the numbers a lot easier when you put them in. So this is the value of x, and y is 8. Yeah? So let's put the values in. 8 is equal to 4/3 times, and put it in 15/2 for x plus c. And now let's simplify. We can see that there's a 4 on the top here and a 2 on the bottom here, so we can cancel there. And there's a 3, and 15 is 3 times 5. So this is going to simplify to 8 is equal to 2 times 5 plus c. So c is going to be 8 minus 10, which is minus 2. Okay, so now we know c, and we know m, so we can put those back in this equation here. So y is equal to 4/3x minus 2, because c is negative. Okay, and we want it in this form here for the answer to the question, so we need to do a little bit of rearranging so that it's equal to 0. So let's just subtract y from both sides, and then we have 4/3x minus y minus 2 is equal to 0. So we can see that if we wanted the values here, a would be 4/3, b would be minus 1, and c would be minus 2. So the answer to question 3.3 is 4/3x minus y minus 2. Also remember that the equation y equals mx plus c, m is the gradient and c is the y-intercept. So c is telling us something as well. C is telling us what exactly? It's telling us where this line RS intersects the y-axis. This is the y-axis. So it says it intersects at minus 2. So R is going to be 0, minus 2. Question 3.4 is determine the x-coordinate of B. So where does this line RS intersect the x-axis? And it's going to intersect the x-axis when y is equal to 0. The x-axis is the line y equals 0. So when y equals 0, so we've already got the equation of this line RS, and we know that y is going to be 0. So 4/3x minus 2, because y is 0, so we can ignore it, is equal to 0. Add 2 to both sides. 4 over 3x is equal to 2. So x is going to be 3 times 2 over 4, which is going to be 3 over 2, which is just 1,5. So b is 1,5 dash 0. Question 3.5 is calculate the size of the angle ORB. ORB. Now RB is going to have gradient 4 over 3 again. It's got the same gradient as RS. So we don't really need to worry about the fact it's B, because all we want is this angle here. So ORB, this angle, and we want that angle, and we know the gradient is 4 over 3, so it's 4 up and 3 across. So to get this angle here, let's just call it theta. If we want to get that angle, the tan of this angle would be the opposite over the adjacent, so the tan of this angle would be 4 over 3. So if we want to find theta, we do tan to the minus 1 of 4 over 3. And then ORB is going to be 90, because here it's 90 degrees, so there's going to be 90 minus theta. Okay, let's do that in the calculator. I've set it to degrees. Tan to the minus 1, 4 divided by 3 equals 53. Now, so theta is 53.13, but we want 90 minus that. So let's multiply it by minus 1 and add 90. So ORB is going to be 36.869 blah blah blah. This 6 we're going to round up because this is a 9, so this becomes 36.87 to 2 decimal places. Question 3.6, prove that QBSP is a parallelogram. QB, it's a bit confusing, QBSP, not QR, QBSP. So we already know that PQ is parallel to BS. So if the length BS is the same as the length PQ, this is going to be a parallelogram. So if PQ is parallel to BS, therefore if the length of BS is equal to the length of PQ, QBSP is parallelogram. And we already know from 3.1 the length of PQ is equal to 10. And we also know from 3.4 that B is 1,5,0. Okay, so all we need to work out is the length of BS. So the length here. So again, we're going to use this formula, which, as I said before, is based on Pythagoras' theorem. So look at it, BS, we want to work out up and across. Let's do up first. That's going to be 8 to 0. 8 to 0. So up is going to be 8 minus 0, which is just 8. And then across it's going to go from 1,5 to 7,5. So across it's going to be 7,5 minus 1,5, which is 6. So to find the length BS, that's going to be square root of 8 squared plus 6 squared. And if you remember from before, these are actually the same numbers. So it's going to be 64 plus 36, which is square root of 100. So that's going to be 10. So BS is equal to 10. So BS equals PQ, therefore parallelogram. Proved. And that's the final question.